Dobra, cześć wszystkim. Nazywam się Michał Rostecki i opowiem wam o Icedragonie, który jest nowym toolem, który napisaliśmy, który ułatwia... okay, should I speak in English or Polish? English, okay. Okay, my name is Michał and I'm going to talk about Icedragon, which is our new tool for making static builds in Rust easier for everyone. And a bit about me. So I would say I'm an open source developer, and my main activity is first of all in Aya, which is a Rust library for writing eBPF programs in Rust. Then I'm active also in Pulsar, which is Xane's open source security agent using Aya. And I'm also active in the Solana community. I'm one of the developers of Agave Validator in Solana. And well, what I'm going to talk about, what's our goal here, because I just showed a slogan about making static builds easy. I mean, first of all, we are talking about static builds. We most likely have in mind the goal to ship binaries to users, to all Linux users, and without worrying about what kind of Linux distribution they are using, without worrying about, burdening them about installing some dependencies. Our goal is to just produce a binary which can be downloaded and just works. And usually, I mean, in Rust it's possible thanks to static linking and thanks to Rust support for musl libc, which is implementation of C library, which can be totally statically linked and doesn't pose any runtime surprises. And also our second goal is to not target only our native architecture, but also to make a cross build. So for example, to be able to produce ARM or RISC-V binary from our x86 machine on which we are developing and making builds. In theory, it's super easy. In theory, you know, you could even say that I should end my talk here, but it's not so easy always. Once your Rust project has any C dependencies and links C libraries, it's becoming a bit less easy. So, for example, here, one of the most common errors is when one of the crates we are trying to build is using OpenSSL and tries to use OpenSSL library. And yeah, if you don't have your system properly configured, usually you can see such an error, or even something a bit wilder like this. Yeah, some package config, like if you see something like this for the first time, you are wondering, what is it about? And let's answer that question, like, what is it about? So first of all, if your crate or any of the crates you are depending on has any C dependencies, they need to be available for the linker on your system as .al files, and the linker you are using or the linker that your Rust compiler is using needs to know where to find them. And what's more, if you are doing a cross-compilation, you need that .a file to be built for the architecture you are targeting. So if you are on x86 host and you are building for ARM, you need the OpenSSL.a files, which are built for ARM, not for your architecture. And well, there are two ways how to point linker to such libraries. Like the basic one is, you know, just finding them by name, and linker is then aware of the system paths where such library should be found. But there is also the second tool called package config, which kind of like has configuration files which points, which have the exact paths for the library. So there's two errors, like the first error is for the first method and the second error is for package config. And well, you need to install those libraries somehow. And if you are, the only thing you have is Cargo Tunche and Rustapp, you would probably need to install those C dependencies with your Linux distro package manager. And if you are installing some, let's say, non-basic libraries, you need to manage so-called sysroots. So you need to create a copy of the whole Linux environment for that target architecture and install those dependencies there. And it's, I mean, usually not the trivial task. I would say that from Linux distros, like Debian and Gentoo are the easiest ones to do that. Like, Debian has a tool called the Bootstrap, and Gentoo has a tool called Crossdev for managing sysroots, so you can like kind of manage those environments for different targets. If you're trying to make a build on Alpine, which you'd most likely like to do if you are targeting musl and trying to do static builds, there is no such official tool. If you Google about how to set up sysroot in Alpine, you get a lot of different random tutorials from 2017. They don't work usually, so it's not so easy. But okay, there is already one tool in the Rust ecosystem which tries to target the problem of cross builds in general. It's called Cross-RS. It's quite easy to use. You just need to set up some container engine on your hosts. It can be Docker, can be Podman. You need to cargo install Cross-RS, and you can start cross-building. But it also doesn't always work. Like sometimes you can still face those errors, and you might still wonder why. And the answer is that Cross-RS is using Debian containers, and Debian is quite known from not shipping static libraries for everything. The situation is improving. They are providing more and more static libraries, but there are still some packages which are uncovered, and there is like always this philosophical discussion whether static linking is good or is bad, and whether we should provide the static libraries. So, well, sometimes if you are stuck on such error, even with Cross-RS, and you just can't find a package with your .air file which you really need to make the cross build you want, the only option ends up to be compiling yourself, right? Like making the build of the C library you depend on from scratch. And here comes Icedragon. So Icedragon is our new project which provides a containerized environment with like many static libraries, and also we plan to add more and more. So far we have enough essentials to make us keep going. And it comes with a CLI, and that CLI allows you to execute cargo and CMake, and we are planning to add more build systems, and then those build systems are executing this containerized environment, and it's made mainly for Rust, but we also sometimes use it to build C projects, pure C project as well. It's still easy. It's still CLI. You can still use it like that, and hopefully it will. Our goal is to make this kind of way of building always work in every case. And as I mentioned, it's not only for Rust. So for example, if you want to cross-compile a C project which uses CMake, and you still want to benefit from the containerized environment that Icedragon is using, you can do this. And what makes also Icedragon unique, and the design decision it comes with, is that it uses LLVM as the main tool chain for everything, including C. So it's basically like it doesn't have GCC, it doesn't have glibc at all, which also solves one corner problem which we are sometimes facing, that in some corner cases there are crates which have build arrays, build scripts, which it will detect that you have GCC, and it will still use GCC even though you set all the environment variables that you want to use Clang. And well, the disclaimer is that it's still very experimental project. We are moving fast and breaking things, but hopefully at some point we'll get stable. And the first run might take a long time because first of all it's downloading on the container image with all the cross environments which are necessary, and then second of all the first run of Icedragon CLI is also bootstrapping your isolated Rust app environment. So like those two things make it pretty slow. Just made this disclaimer in case you want to try it out in your hotel room here, like during the conference. Well, yeah, I mean, always, if you are interested in this project and you notice that there is some library which you need and it's not shipped, like, feel free to ask for adding it or propose adding it. You can just cargo install it. You can also build it from GitHub. I will also show a little demo of it. So this is how it's building Pulsar, which is like the main open source project that is developed at Exane. So we are building an ARM musl binary on an x86 system here. It's gonna take a bit of time. I didn't want to shorten it, just to like really make sure that it's making a whole build. And it's all done inside the container with your source code being mounted as a volume. And this project, has quite a bit of C dependencies. It depends on OpenSSL. It depends on SQLite. It also calls Clang to directly to compile some BPF modules which are still in C. And the build is finished. So now we can check whether the binary which is produced is really an ARM binary, and it is. It's ART64. And we can try to like run it quickly with the QEMU user space emulator. And yeah, it works. So it was successful. It was not so easy without Icedragon in our case. Exane is hiring, so if you are interested in working either on more low-level stuff or on backend, check out the website. We are also hiring the technical project managers. And that's it. Thank you for listening.